Chapter 14 in class exercise 2, problem number 14.5. Determine the required height h of the roller coaster so that when it is essentially at rest at the crest of the hill A, it reaches speed of 100 km per hour when it comes to bottom B. So this is one question. There are two questions here, and the second question starts from here. Also, what should be the minimum radius of curvature rho at track B so that the passengers do not experience a normal force greater than 4 times their weight, which is 4 mg, or it's also called 4g force, and its value is, if you substitute g equal to 9.81, then the number is 39.24 times mass newtons. Neglect the size of the car and passenger. That means consider car and passenger as a particle. So as there are two steps to this problem. In the first step, we will calculate the required height h, and in the next step we will calculate the radius of curvature rho. Okay, so particle has initial kinetic. So there, let's use nomenclature A and B. So TA is the initial kinetic energy, which is 0 because it's at the rest at the the coastal car is at the rest at the crest of the hill, and when it reaches B, its speed is VB is 100 kilometers per hour. So we need to convert this into meters per second, because when we use acceleration, gravitational acceleration, that is in meter per second square. So we want to make sure that all the units are in the same order. So let's apply this concept of work energy, that initial kinetic energy plus work done going from A to B is equal to final kinetic energy at B. So initial kinetic energy is 1/2 mVA square. Now work done is only work done due to gravity because of the weight of the coaster car and this height h. Now since the coaster car is traveling downward, and so as the gravitational force also acts downward, the work done by gravity is positive. So it's W multiplied by h, and that's the only force, equals 1/2 mVB square. What we haven't done here is we should have converted VB into meters per hour. So 100 kilometer per hour is 100 multiplied by 10 to the power 3 meters, and then to convert hours into second we need to divide by 3600. So this is the conversion is 27.77 meters per second. That is the speed of the coaster car that we would like to have at the point B. Okay. So VA is 0, so this is 0. W, weight of the coaster car, is that given? It's not given, so we will write that as mg times h equals 1/2 mVB square. If you divide by m on both sides, then m and m will get cancelled, so we get gh is equal to 1/2 VB square. In other words, h is equal to 1/2 VB square divided by gravitational acceleration g. So we can substitute the numbers here. So this is 1/2 times 27.77 square divided by gravitational attraction is 32.2 because it's in feet per second square. Okay, so sorry, its gravitational attraction is 9.81. It's FPS problem, so it's 9.81. So we get 39.30 meters h. Okay, so what it means that if the coaster car comes down from the height 39 meters, then by the time it reaches B, work done by gravity will increase the kinetic energy to 27.77 meter per second square, or 100 kilometers per hour. So that's one part of the question. Now for the second part, this motion is curvilinear. It's the curved motion, so we need to apply normal tangent coordinate system at B. So let's draw the normal tangent coordinate system at B. So I'm just drawing point B here, which is at the bottom of the loop. So coaster car is traveling in this direction, so this is our tangential axis and this is our normal axis. And this is coaster car, we considered that as a particle, then the weight of the particle x downward, W, and the normal force that it experiences, N, is in the upward direction. Now that normal force value is given as maximum 4 times mg, which is 39.24 times m. So we can substitute that value here. So 39.24 m, and this w is equal to mg. So this is 1 time mg. This is 13. This is 39.24 times m. We can actually substitute value of g here. So it's 9.81 m, and this is 39.24 m. Okay, so these are the two forces, and as a result of this curved path, roller coaster experiences normal acceleration in the direction of normal coordinate axis. So we can apply this formula from chapter 13, that equation of motions along normal coordinate axis. Sum of forces in normal direction is equal to mass times normal acceleration at B. Okay, because this is point B. So, and normal axis is go vertically up is positive for us. So going up is positive. That means this number 39.24 m is positive, minus 9.81 m equals m times acceleration at B. It's normal acceleration, so it's v squared divided by rho. This is again from chapter 13, equations of motion. Okay, so we can substitute these numbers here, and since we don't know m is on both sides, we can actually divide by m on both sides. So we get 39.24 minus 9.81 is equal to vb square divided by radius of curvature. And vb is 27.77 that we have calculated before. So we can calculate radius of curvature using this formula. That will be 26.20 meters. So we got our second answer as well. Okay, so we have applied work energy concept between A and B, and we calculated the height. And we have applied normal tangent coordinate system and equation of motion at B and calculated radius of curvature.